Next up, let's take a look at deploy and manage virtual networks. Azure Bastion is a service you deploy that lets you connect to a virtual machine using your browser and the Azure portal. The Azure Bastion service is a fully platform-managed PaaS service that lets you provision inside your virtual machine. It provides secure and seamless RDP SSH connectivity to your virtual machines directly from the Azure portal over TLS. When you connect via Azure Bastion, your virtual machines do not need a public IP address, agent, or special client software. Bastion provides secure RDP and SSH connectivity to all the VMs in the virtual network in which it's provisioned. Using Azure Bastion protects your virtual machines from exposing RDP SSH ports to the outside world while still providing secure access using RDP SSH. Azure Bastion deployment is per virtual network, not per subscription or account or virtual machine. Once you provision an Azure Bastion service in your virtual network, the RDP SSH experience is available to all your VMs in the same virtual network. Network security groups are associated at a subnet level or at a NIC level. When associated at a subnet level, it applies to all the VM instances in the subnet. Effective security rules returns all the configured NSGs and rules that are associated at a NIC and subnet level for a virtual machine, providing insight into the configuration. In addition, the effective security rules are returned for each of the NICs in a VM. Using Effective Security Rules view, you can assess a VM for network vulnerabilities such as open ports. You can also validate if your network security group is working as expected based on a comparison between the configured and the approved security rules. You need to understand for the exam how traffic is evaluated. For inbound traffic, Azure processes the rules in a network security group associated to a subnet first, if there is one, and then the rules in a network security group associated to the network interface, if there is one. For outbound traffic, Azure processes the rules in a network security group associated to a network interface first, if there is one, and then the rules in a network security group associated to the subnet, if there is one of those. The IP Flow Verify feature of Azure Network Watcher can also help you determine if network security rules are preventing communications between a virtual machine and an endpoint. In the Quick Start link, you will deploy a virtual machine and then check communications to an IP address in URL from an IP address. You will determine the cause of a communication failure and how you can resolve it. As we always mention, hands-on work is the best way to learn and commit that learning to memory when studying for the exam. ExpressRoute lets you extend your on-premises networks into the Microsoft Cloud over a private connection with the help of a connectivity provider. With ExpressRoute, you can establish connections to Microsoft Cloud services such as Microsoft Azure and Microsoft 365. Connectivity can be from any to any IPVPN network, a point-to-point Ethernet network, or a virtual cross-connection through a connectivity provider at a co-location facility. ExpressRoute connections don't go over the public internet. This allows ExpressRoute connections to offer more reliability, faster speeds, consistent latencies, and higher security than typical connections over the internet. The links on this slide should be reviewed as they represent some of the key things that need to be done when setting up ExpressRoute. There are many possible things that can affect external networking. Here are some factors to consider when troubleshooting external networking issues. Check whether the network adapter is in a failed state. Check the network security group settings. Remember that rules have a lower number will be matched first. For example, if you have a rule that has priority 1000 and 6500, the rule that has priority 1000 will be matched first. IP Flow Verify looks at the rules for all network security groups applied to the network interface, such as a subnet or a virtual machine NIC. Traffic flow is then verified based on configuration settings to or from the network interface. IP Flow Verify is useful in confirming if a rule in a network security group is blocking ingress or egress traffic to or from a virtual machine. The virtual network documentation online is massive. Nonetheless, from a study perspective, it's still worth a download of the PDF. Then you can search by keywords such as troubleshooting and/or external networking. Azure Application Gateway is a web traffic load balancer that enables you to manage traffic to your web applications. Traditional load balancers operate at the transport layer, OSI layer 4, TCP and UDP, and route traffic based on source IP address and port to a destination IP address and port. Application Gateway can make routing decisions based on additional attributes of an HTTP request, for example, URI path or host headers. For example, you can route traffic based on the incoming URL, So if images is in the incoming URL, you can route traffic to a specific set of servers known as a pool configured for those images. If /video is in the URL, that traffic is routed to another pool that's optimized for videos. This type of routing is known as application layer or OSI layer 7 load balancing. Azure Application Gateway can do URL-based routing and more. The Application Gateway infrastructure includes the virtual network, subnets, network security group, and user-defined routes. Azure Application Gateway consists of several components that you can configure in various ways for different scenarios. Front-end IP addresses, listeners, request routing rules, HTTP settings, and back-end pools. So make sure you read the documentation on here so you understand each of these and how they're constructed. Azure Virtual WAN is a networking service that brings many networking, security, and routing functionalities together to provide a single operational interface. These functionalities include branch connectivity, site-to-site VPN connectivity, remote user VPN, private connectivity such as ExpressRoute, intra-cloud connectivity, VPN ExpressRoute interconnectivity, routing, Azure Firewall, and encryption for private connectivity. A site-to-site type of connection requires a VPN device located on premises that has an externally facing IP address assigned to it over an IPsec or IPv1 or v2 VPN connection. Once you have this type of connection, you may also want to then configure a custom IPsec policy. Custom policies are helpful when you want both sides, on-premises and Azure VPN Gateway, to use the same settings for IKE Phase 1 and IKE Phase 2. A user VPN connection requires the VPN client to be configured on the client computer. When connecting to your virtual hub over the IKE v2 protocol, you can use certificate-based authentication or radius authentication. However, when you use the Open VPN protocol, you can also use Azure Active Directory authentication. Once you have established a virtual WAN with ExpressRoute, you may also then want to configure encryption. This can provide an encrypted transit between the on-premises networks and Azure virtual networks over ExpressRoute without going over the public internet or using public IP addresses. In each of these cases, review the links to understand the steps to setting these up, as well as anything that you can configure on the connections.